let's pass a null pointer. Okay, so now to do this, let's look up so we have to test it on something. Let's not test the init Gauss for now. Let's just focus on the thing that. So exponential function. I don't know if I can pass the address of an exponential function. If not, we can just define it. Okay, so the exponential function integrated between 0 and 1 is 1.78281828459045. Okay, that's a number, I guess. That's okay. Let's forget about this, and let's forget about this too. Forget about this. Okay. Let's print so and integrate Gauss from A to B, so from 0.0 to 1.1, but actually here because C is sometimes not too bright. Let's just make sure. It's one of these things, like most of the time it works and yet sometimes it doesn't work, and so you either have to pay attention to it or you have to work around it so that you don't need to pay attention. sometimes it looks like you're doing something repetitive and dumb, but actually you're just making sure certain things are out of the way, because these things have real bugs in them sometimes. You need to be able to tell. That was stupid of me, but hey. Info. Like, the more things that could possibly go wrong, it's just harder. When things are actually hard, okay, that's good. Instead doing that, we will we'll say int I for I equals to 3, I less than 30, I plus plus. So by the way, this formula, you know, it's kind of you can doubt it. It's not self-obvious, but because you do a test, you know, what are the odds that we did a critical mistake in this? Like, if you screw even one of these things up, actually 0 to 1 is not a good example. Yeah, but okay. One of the things we can do is to go from 1 to 0 and see what happens. We should get the opposite. Okay, so printf error and then it's just integral exp minus except that 3 becomes I. Or it's not exactly 0. Okay, so let's do log. Because it's not, it's going to give you right. You can't take log having a negative number. So Again, the dumb solution is to square so then you need to take the square root, so you need to divide by 2, 0.5 times just one of the properties of the log. So and it's log base e. Okay, log base e. I would prefer it if it was base 10. We can still say a few things. So between here and here, the order of the error has gone down. So it's almost the exponent is almost twice as negative, which means we've doubled the number of zeros between the error and the digit, approximately. And we see that there's a kind of peak around here. Okay, forget about the noise. This kind of tendency, okay, minus 14, and then goes up to minus 23, around that, and it goes down. Should go down as fast as that. Maybe this is not right. Say 3 plus equals 5. We also need to print, say n equals I think there's a problem, and the problem is maybe in the roots. If we look at